What's up, y'all? It's Afueko. I'm just gonna skip the intro today. Today, we're gonna do facial recognition with TensorFlow. We're gonna be recognizing the faces of the 3 most popular members from Destiny's Child, Beyonce, Kelly, and Michelle. We'll first create a dataset of their labeled faces. After that, facial recognition happens in 2 parts. We first need to detect every face in the current frame, then we need to identify each detected face. In this video, we'll first talk about data generation and loading. All our data comes from the music videos available on the Destiny's Child YouTube channel. Then we'll talk about model design and train some recognition models using the data that we generated. After we do that, we'll look at some full videos analyzed using the models that we trained. If you want the code for this video, it'll be at this link, which is also in the description. Let's get into it. The first thing I did was download the videos, extract faces, and annotate the data. I made this little app after downloading all the Destiny's Child videos and clicked through identifying each face that was detected with the facial detector. This was definitely the most time-consuming part. After this, data loading is pretty simple in TensorFlow. TensorFlow has an image dataset loader that expects each class to be in its own folder. All we have to do is organize the data in that way, and it takes a single call to load the data. Here are some examples of our training data. Beyonce dominates this dataset because she's front and center in all of these videos. This will probably have a negative effect on performance. Let's get into model design. Our model is going to use the VGGFace pre-trained encoder. VGGFace is a model based on the VGG classification model, but it's designed for facial recognition on the VGGFace dataset, which has over 2,000 unique faces. We only have 4 faces we want to identify, so we'll just take the encoder by setting include top to be false. Then we'll add our own classifier that we'll use to identify one of the 4 classes: Beyonce, Kelly, Michelle, and unknown. These unknown people might actually be unknown, but some of these people were actually in Destiny's Child once, i.e. LaToya and Latavia, but they're not in most of these videos, so it's a little hard to make them their own class. No shade. The classifier will be a series of linear layers that takes us down from the number of features to the number of classes. We'll be using the Keras submodule in TensorFlow for this. Keras was once its own library, but TensorFlow adopted it because it makes model design based on standard layers pretty simple. Now onto training. For training, we first need to evaluate the model, which returns logits, which can be thought of as log its blank, meaning it's the log probability for each class. From there, we turn those log probabilities into percentages, and if that percentage is greater than 50%, we classify it as a face during training. During evaluation, we simply take the highest predicted class, as we know only a single face will show up in each image. We're going to train this using the Keras built-in optimizers and losses. In this case, we'll use the stochastic gradient descent and the categorical cross-entropy loss. The sparse categorical cross-entropy loss takes in one-hot vectors, which means that you can classify multiple things at one time. Using this method, we get some pretty decent results. One thing to note is that Beyonce and the unknown category's accuracy is much better than everyone else. We can also create a balanced dataset by limiting the number of images from the larger classes. While this does improve accuracy overall, and for the Kelly and Michelle classes, the Beyonce and unknown classes do suffer. Looking at the results on live videos, we see that overall accuracy is okay, but it could use some work. Our dataset is very small, unbalanced, and doesn't have any real standardization in terms of image quality and resolution. If we were to try to create a better dataset, these are all things we would have to consider. We could also improve our output by improving our model. Instead of just creating a larger model with more parameters for classification, we could also include frame-by-frame correspondence. We know that faces aren't usually changing at every single frame, which happens every 1/24th of a second. If we included that signal in our original model, we could avoid inconsistent prediction like this without having to add more data. We could also add the constraint that only one of Beyonce, Kelly, and Michelle shows up in a frame. This could actually be a bad idea, as in this video there are clones of them or something. But in general, making sure that you have an understanding of the reality of your system and making sure there's consistency between that reality and the implementation of your system is always a good way at improving your machine learning models. That's it for this video. In our next video, we'll be bringing back that DCGAN model that we used in the virtual environments video to actually generate some fake faces that look like Destiny's Child members. If you're interested in that video or anything that I'll be posting on my channel, like this video and subscribe to my channel, and also hit that notification bell so you're notified whenever I post a video, which I think will be... Actually, I don't know when that's going to be because I'm abandoning my upload schedule. If you want the code for this video, it'll be at this link, which is also in the description. That's it for this video, and I'll see you on the next one. Later!
I don't need no cash now. I don't need the fame, and I don't like the games, and I don't like the way you want me to be wife now. I'm in it for the games.